All right, let's take a look at a few different ways double angle formulas might show up. Although it's not limited to this, there are many creative ways to set a problem involving double angles. So first off, in the upper right hand corner, I wrote the formulas. The first one you probably will use often enough where it may just come to naturally memorizing that one. The others maybe not so much, but I don't think memorizing them should be too much of a focus anyways. More so how to use these. All right. So let's look at this first example of tan x equals negative 8. X, that's a little in symbol, looks like an E. X is in quadrant 4. Evaluate sine 2x, cosine 2x, tan 2x. All we are given is tan x. Well, looking at the tan 2x, we could go ahead and solve that one now because we have tan x. We plug it in the formula and go. So let's do that really quick. So tangent 2x, the formula says you take tan x and multiply it by 2. So 2 times tan x is negative 8 divided by 1 minus tangent x squared. So negative 8 squared. So we get negative 16 over 1 minus 64. So negative 63. And besides changing those to positive, that's all we can do, right? Because 16 is power of 2 and 63 is not even. So 16 over 63 is the double angle. Notice we never found the angle, right? In fact, I don't care what the angle is because it doesn't require that of me. It just asks what is tangent of double that angle. Since we're way over here in quadrant 4, right, the angle is somewhere in here. I don't know where exactly, but again, it doesn't matter. But double that angle, I got positive, so that does tell me that I'm somewhere, right? I would have to be either here or quadrant 1, since using all students take calculus. I know that tangent is positive in quadrant 1 and 3. Again, we don't care, but this, and it's going to have to be quadrant 3, right? Because there's no way we could double that and get to quadrant 1. Okay. Side fact. Now, look at sine 2x. I need both sine and cosine. I'm not given that, right? I know sine over cosine is tangent. I don't know if that's the way that I want to approach this, though. So my thought is this. I'm in quadrant 4. I know cosine will be positive. Sine will be negative. Okay, because we're in quadrant 4. So now I'm not worried about the signs. I am just going to draw a triangle. Not drawing a scale, because you'll see why here in a second. Tangent is negative 8, so again, we don't care about the sign for now. Opposite over adjacent, and that's why I said not drawn a scale. Opposite, I have 8. Adjacent, I have 1. But using Pythagorean theorem, 1 squared plus 8 squared equals c squared, right? Or h squared. That'd be 65. So c is the square root of 65. Again, we're not going to count positive or negative because I already know sine is negative. And sine is O over H. So 8 over square root 65. Should we rationalize it? Yes, but that our result is not looking for sine or cosine. We're looking for sine 2x. So I'm going to leave it for now. Cosine adjacent over hypotenuse, 1 over square root 65. Now I have everything I need for the formulas, right? Sine 2x says to do 2 times sine x, which is negative 8 over square root 65, multiplied by cosine, 1 over square root 65. And I get negative 16 over square root 65 times square root 65 is just 65. And that's it. So cosine now, there are 3 formulas over there. Really, it's just pick whichever one you like the best. I guess I like the bottom one the best, only because I only have to do cosine squared once, and cosine is 1 over square root 65 opposed to sine, where it's 8, but again, it won't matter. Any one of those 3 formulas will yield in the same result. So cosine 2x, I take 2 multiplied by cosine squared, so 1 over square root 65 squared minus 1. So that becomes 2 over 65, since 1 squared is 1, square root of 65 squared is 65 times 2, subtract 1. We need an LCD, right, times 65 over 65. So 2 subtract 65 is negative 63 over 65. And as we kind of guessed, right, we were in quadrant 3, sine we got negative, cosine we got negative for the double angles. So that also checked out. Awesome. All right, we had one angle and we now found all 3 double angles, all 3 trig functions of double that angle, even though we never found the angle. So that's pretty cool. All right. In all of these formulas, you may end up simplifying or verifying equations, identities, and verifying can often be easier. It's more work, but we know what we should get, right? Where simplifying, depending on the problem, sometimes you don't really know how far you can simplify. But you'll have a list of formulas, and always, like, this was a good hint in this one because I'm doing a double angle formula video, but always kind of compare what you have to the formulas given and see what it resembles most, and then go from there. Now this one is a very close resemblance of sine 2x, right? I mean, it goes 2 sine x cosine x. So here's why I wanted to do this example. Just because I have sine 8x and cosine 8x doesn't necessarily mean the formula doesn't hold. Okay, the formula I wrote both have x. That doesn't matter. I could have said theta. I could have said sine 2 theta equals 2 sine theta cosine theta. So here's what we're going to do. If I thought of this as, first off, I want 2 sine cosine. So I'm going to go 2 times 2 sine, and then what I'm going to do is say u, cosine u. All right, now that's going to make sense here in just a second. I'm just saying that u is 8x. Well, if I'm claiming that u is in place of 8x, right, then this is also u, cosine u. Now that looks good. I also now have the 4 I split to 2 times 2 because here is the double angle formula. It says if I have 2 sine of an angle, cosine of that same angle, I could change that to sine 2u. But the original problem didn't have anything to do with u, right? So all I'm going to do last is replace that u back with 8x. So since u is 8x, right, and I have 2u, 2 times 8x, then my final result will be 2 sine, I'll go ahead and use parentheses, but I talked about this in another video. Often I don't do parentheses there because I know that sine 16x, all sine of all of that, but really that is what we're taking the sine of. All right. So I can change 4 sine 8x cosine 8x into 2 sine 16x. Those are identities. I simplified that. I would have to admit it does look a bit cleaner, right? It's sine of one angle rather than sine and cosine. All right, last one. We're verifying. If we look at cosine 2 alpha, all three of these don't have anything to do with tangents. Now I can make the substitution over here. Okay, I could change it to one of those. I don't know that that's going to get me very far. Okay, maybe not. One trick with tangent, anytime we have tangents, change it to sine and cosines, and then try to simplify from there. So I'm going to change the right-hand side. I'm going to leave the left-hand side alone. Okay, 1 minus sine squared over cosine squared, and then 1 plus sine squared alpha over cosine squared alpha. Okay, one trick with all these multiple fractions is to multiply by the LCD in the numerator and denominator. Okay, clear the fractions. So now I have, in the numerator, I have cosine squared alpha minus sine squared alpha, right, since I distribute, and here they canceled. And in the denominator, same thing except for I have a plus. But sine squared plus cosine squared is 1, right? This denominator is equal to 1. So I just have cosine squared minus sine squared. Well, that was one of the identities, right? Cosine 2 alpha is cosine squared minus sine squared. And therefore I'm done. I have the same thing on the left that I do on the right.